Okay, we're a couple of minutes past, so we will kick off. Thanks to everyone who's here, and welcome to our webinar today on research software engineering for health research. My name is Rosie Wakeham. I'm head of training at HDR UK, and I'm delighted to introduce our trainer today, Heidi Seibold, who will be delivering the webinar today. I'm going to briefly return at the end to talk about some other things that we have going on at HDR UK. And just to let you know that this webinar is being recorded, and feel free to put questions into the Q&A function in Zoom, and Heidi will get to those during the course of the webinar. Okay, over to you, Heidi.
Thank you so much, Rosie, and thanks for having me again at this webinar. I'll start sharing my screen so that you can actually see the slides. Here we go. All right, I'm super excited to be here again. We're going to talk about research software engineering and health research. Since this is a 90 minutes webinar, we're not going to go into every little detail of research software engineering and health research, obviously, but I'll take like a big overview on like what are the most important bits to get started with if you're interested in improving the way you write code in your research. My name is Heidi Seibold. I'm a founder of the Digital Research Academy. We do training on open science, data literacy, research software engineering, all the exciting parts of digital research. And today I'm really excited to do this webinar for HDR UK. So I'll start off with the question of why should we care about research software engineering? A lot of us want to do research and focus on that and just do good research, right? But in reality, we've seen over and over again that better software means better research. And I'm using the slogan from the Software Sustainability Institute here because I think it's so fitting to why we should care about research software engineering, because if we don't care about it, then we'll produce code that's not reproducible, we'll produce software that's not usable or user-friendly, and we'll just waste a lot of money and waste a lot of research. So that's like the overall reason why I think you should care. There's a lot of other smaller reasons for that. And I want to start with an example of my own work. So I did my first software when I was a bachelor student. It was actually my bachelor thesis. And I wrote an R package about a topic that I'm honestly no longer working on. So it was about unexploded bombs from the Second World War and figuring out the risk zones. So the package is called high risk zone, the risk zones of where we expect that there are still unexploded bombs in the ground based on data that we have from like aerial pictures from the Allies from after the Second World War. So I was super excited to do this as a bachelor thesis. It sounded like a cool project, and it really was. But honestly, it was clear from the beginning that I wouldn't maintain the software forever, right? And later on, I moved more into health research, and I wasn't interested in this topic anymore. But luckily, there was another student, a PhD candidate actually, who did similar research and wanted to extend the package. And so I was like, hey, do you want to become the new maintainer? And since it was properly organized, as it was already an R package published on CRAN, it was really pretty easy to hand this over to someone else. It was well documented, well structured, and it was clear to that person without me having to give big of an introduction of how it works, that and he just could take it over and continue to maintain it. So this was a nice example from the perspective of my side, like I didn't have to maintain it anymore, but still the package would live on, but also from the perspective of my supervisor of my bachelor thesis, because he obviously had an interest in the research to continue and the package to stay on. And so he was really excited that there was a new maintainer and someone who would take care of the package because he couldn't. A couple of other examples I thought would be a nice way to start off this webinar. So I thought I'll just ask the internet what they think are good stories of why we want to do certain things in research software engineering, like getting organized, creating useful code, writing code together, or using automation. And I got a lot of really cool responses to my question that I sent out on Mastodon. And so here's one that I really liked from Kern about a story where he says like he helps people figuring out the setup of software on cameras. And he got tired at some point of like explaining the setup for different cameras to different people over and over again. And so he just wrote a software that does the setup for them. And now he says the software decreases failure rates by 99.9%, removing the burden of the PhD student. So automation in that case through software really helped the research. Another response that I got that's something that I hear over and over again from people is that when you join a new project, you sometimes get to take over or have to take over code that's really not documented at all. So the person describes that there wasn't even a single comment in the entire code base. So it took them a lot longer than it should have to really get started with working with the code. So creating useful code, organized code that you can hand over to someone new, like in my example with the bachelor thesis, is just really, really helpful. And it can really hurt the productivity of new people when they come in to a project, if that's not the case. So one final example that I wanted to share is the one that Steve posted. And Steve started writing a software by himself, and then someone else came in and said, like, hey, can I join you? Can we write this together and be like do like peer coding on this? And so he writes about this wonderful experience with this other person where they started having weekly meetings and working through the code together, writing tests for each other and all that kind of stuff. So it was really a wonderful example of how writing code together can make the software better and also make the experience of creating code a lot better. All right, so I want to just stop here real quick and see if there's already some questions or comments or where you say, oh, that's a nice example or an experience that you had where you say, oh, this is exactly how it was for me. So feel free to put that in the Q&A and I'll see if I can already respond to some questions or comments right now. Let me just see if I can see the Q&A somewhere. I think I just stop. All right, I just see no open questions at this time. All right, keep them coming. So if you have any questions throughout or comments about any of the things or stories that I talk about, feel free to jump in. So where did the browser go? Here we go. All right, so I talked a bit about the stories of like why research software engineering matters and why doing these good practices can help you. Now let's talk about how you can actually get started. And my suggestion when getting started on things like that is always to pick something that's easiest for you, or if you want to do it with the whole team from the get-go, then pick what's easiest for your team. There's so many things that you can do, and probably a lot of things that we can do better. And starting with the things that are easiest are the most is more rewarding, and we can't do perfect right away, right? So I'll show a couple of different examples of like what can be done better, and you can just pick and choose from those. I'm not going to say like you have to do all of this at once. And this is really important to me because I don't want people to like get started and then feel overwhelmed right away, and then we don't implement any of it. So to start, pick what's easiest for you or your team. All right, and I'm going to start with something that's maybe not as exciting as other topics, but getting organized is a very, very good first step when it comes to research software engineering. What do I mean with getting organized? So number one is using good names for things. If we have names for functions that are just like foo1 through foo100, then nobody will know what this function actually does. The same with file names and folder names. Just use names that mean something to you and that are also computer readable, obviously. So that's suggestion number one. Then suggestion number two is organizing your files and folders. I have this little image here that represents the opposite of that. So having an organized office like is a good metaphor of having an organized folder system on your computer. So if you have, for example, a research project, think about how do I structure the folders in that research project? Do I need a folder that's called data? Do I need a folder that's called source code? Do I need a folder that's called, I don't know, journal communication, so that everything is organized and then people actually know where to find things. The same is with software projects. When you program in R, then it's already a structure is already given to you through how we generally structure our packages, but it's not the same case for other programming languages. So thinking about a good folder structure and organizing your files and folders well really does make a difference. And then one of the examples mentioned, there wasn't even a single comment in the code. Yeah, having code comments can be really, really helpful, especially if the code is a little bit more complicated. So I used to develop new machine learning and statistical methods for personalized medicine, and there sometimes the code was pretty complicated, and I wouldn't remember a few months later what it actually does, because it's not so simple a lot of times, and I would have to go through it, and just putting a comment here and there that helps you figure out faster what this code is supposed to do can be really, really helpful, both for yourself in the future, but also for collaborators and people who come after you. Then the last thing that I recommend is formatting your code. So sometimes people say, well, if I organize my code well from the start, I don't need as many comments, and that may be true. So if you have your code formatted so that it's nicely readable and not like a huge long line for one function, but structured in a way that is readable easily, then that can really help a lot. Wonderful. So let me again talk about a little bit of an example here, a negative one this time from my own research. So my first research project, that was still during my master's, I did a really complex statistical model for gene expression data. And I first started out doing the computing on my local machine, my desktop machine, And it turned out that the models were getting too big for my local machine. So I had to go to the Institute's cluster, and I didn't really know in the beginning how that works and how to work there. So I crashed the cluster a couple of times in the beginning. And then at some point, the IT guy was like, "No, Heidi, I think our Institute's cluster is too small for you even." So I had to go to the high performance computing system at our university, and that was even more complicated. And for each of these attempts, I needed to change the code a little bit every time, and had in the end copies of similar code, and a lot of them because it was several different models, several simulation studies. And it just got so confusing and so messy. So my head and my computer looked like this image that we have here on the right. So I just, yeah, that's how I got into all this thinking about reproducible research, about getting organized, is through yeah, just that experience from myself, from my own side. Yeah, I think we have questions now, but I don't really see them. How can I see them? Maybe Rosie, can you help me with the questions because I can't.
Yeah, no problem, sure.
Yeah.
So the first question, as a researcher, I love what you're saying, but the phrase RSE sounds more intimidating and outside my comfort zone. Do you have any comments on that?
Very good comment. Thank you for that. So I do understand that that's how it feels. And being an RSE, so a research software engineer, doesn't really need to be you, right? So not every researcher, in my opinion, has to become a research software engineer. If you're working with code, it makes sense to think a little bit about good coding practices, and this webinar is just for you. If you want to become a research software engineer, then you can, but you don't have to. And there's experts for that. So I think especially in the UK, most universities now have RSE support groups, or RSEs within different research fields that can actually help you with a lot of things. So I recommend, if you want to become the expert, you can, but you don't have to. And there's people who want to do that and who you can ask for help. So reach out to your RSEs at your university or research institutions, wherever you are, is I guess my response to that. Are there any other, Rosie?
Yep, there's two more. So first one, is research software engineering in the health space somehow different than everywhere else?
That's a good question. I guess yes and no. So the things that I talk about today, they're pretty universal. Although the examples that I'm showing are mostly from health research, and since that's what we're talking about today, and that's what my work has been about. But in general, it depends, right? So if we're working in health research, obviously we need different kind of code than if we work in physics, for example. But like the basic good practices, they're really more or less the same, I would say. Yeah, I don't see any difference in that. So if I would talk to physicists, I would give them the same suggestions. Maybe I would talk a little bit about different examples than gene expression data because they're maybe interested in different things. But the basic good practices and also tools that we use in different fields are actually the same. Yeah.
Thanks, Heidi. Last one.
Yeah.
Emma would like some tips for code scripts with very quick or one-time uses that you may not want to clog up your repo with. Do you store these in a separate folder?
That's a good question. So it really depends. Is that a code script where you're just trying things out? I often have if I have a research project and I have, sometimes I just want to try things out, see how different visualizations look or something like that. For that, I actually have a folder and I call that folder Sandbox. So I know that in this folder, there's the code where I'm just trying things out that I don't want to delete. I want to keep it, but don't really think this is going to be in the paper, or only bits of that is going to be relevant for the paper. So yeah, I do have, usually in my research project, I have a folder that's called Sandbox, where I'm storing like the code for the things, the scripts for the things that I just want to try things out. I hope that answers that question.
Thanks, Heidi. That's all the questions for now.
Excellent, wonderful. So in that case, I'm going to go on and talk about the next topic, which is creating useful code. And here I brought 3 suggestions for you today. The first is to start thinking about the user, right? Who's going to be the user of my software? Is it going to be other software people? Probably not, or oftentimes not. Oftentimes it's going to be researchers or other applied people, right? So think about those users. What do they know? What do they struggle with? And when you create the code or the documentation, think about what they need to really be able to use the code. Then the second point ties really well into that, which is write documentation, right? Obviously, if we want code to be useful and if we want people to understand what's going on, we need to write documentation, because almost no code is self-explanatory. If it's self-explanatory, it's usually very, very simple. And even then, maybe we think it's simple now, but we might not think about the same about it in like 6 months, when we've forgotten half of the project already. So writing documentation is a good idea. There I recommend having like a README in your repository, having some inline comments, but also having some deeper documentation for more complex, like if you're going more towards software, right? So to have a documentation of every function, maybe also with examples how to use it, that's usually really helpful. And the third recommendation is using a license. And like, as an open scientist, I'm obviously into open licenses, but just thinking about licenses in general is a good idea, because if you don't put a license, then people are not going to know what they're allowed to do. And usually the answer, at least here in Germany, the answer is you're not allowed to do anything if there's no license coming with it. So there's a nice license picker. If you go to choosealicense.com, it really guides you through the process of choosing a license for code. So that can be really helpful, so that others actually know, can I reuse this code? Can I reuse this code only if I also use an open license? So there's just different questions that people have when they see your code. They maybe want to reuse it or use it to reproduce the results of your work. And they can only do that if you have a license and clarify with them what they're allowed to do with it. Again, I want to share an example of my own work. I wrote an R package for my PhD that's called Model4U. It's an R package that does stratified and personalized treatment effect estimation. So we know that in clinical trials, for example, we estimate the treatment effect of a certain new treatment. And this package does that, but tries to identify the patient characteristics that have an effect on the treatment effect. So maybe men have a lower treatment effect than women, or people with a high value of, I don't know, creatinine in their blood have a higher treatment effect than others. So this is what the R package does. Also here, in this example, I just wanted to share a couple of like good parts and maybe also not so good parts about the things that I just talked about. So this package is a simple R package. that builds on the work of my co-authors. And so there's another package that is the basis for this package. So it's really cool. They thought about the users that were going to come after it, and also about the people who might build software upon their software. So that was really, really cool. And I created this package specifically to make it more user-friendly for these use cases of treatment effect estimation, because the package that I based it on, it's called PartyKit, wasn't really that user-friendly for people that want to do this specific thing, right? So there I had to think a lot about who are going to be the users, going to be medical researchers, people in pharma, and what do they actually need. I did a lot of documentation with a lot of examples so that people can pick and choose from the examples that are most similar to what they want to achieve. And I added an open license, in this case, the GPL license. I also want to share that not everything is great about this package. After my PhD, my research moved into a different direction. I'm focusing more on open science now, and I'm doing more training now, less research. So I lost a bit of interest in maintaining it. So it doesn't currently get updates or improvements. I actually have an email in my email inbox right now from CRAN requiring me to do some updates, but I'm here instead doing training, focusing on that at the moment instead of making sure that the package survives. But I will. I promise I will. All right. So yeah, that's until here. I see that there's more questions, but again, Rosie, I don't know why I can't see the Q&A.
No problem, I can do those. So the first one, you might have some comments on this, otherwise they can email the Learn our inbox, which I'll give the address for in a moment for some more info. But the question is, I am doing my master's in data science and I'm interested in becoming data science researcher in healthcare. Can you provide some tips? Understand I'm a bit out of the scope of this seminar, but anything would help.
Oh, wow, that's a big question. I guess learn things that you need to know in order to do the work that you'd like to do. Yeah, but maybe Rosie, you can put links. You said you have
Yeah.
links, right? Yeah. So
Yeah, I'm just putting our the HGR Learn email account into the chat, and so you're welcome to get in touch with us, and we can hopefully help you. So the next question: what level of explanation for code is a good choice for the documentation?
yeah, good question. I think it depends, right? So there's always a trade-off that we need to make in terms of like our time and the optimal level of documentation, and we're gonna probably be making that trade-off more into one or the other direction. So my suggestion is do as much documentation as you as you can afford in terms of your time. And think about the user. How much documentation do they actually need? Maybe they don't need that much. Think about the people, like maybe you're not going to be around forever doing this work. Think about your co-workers of the future who will take over the project. What would they need? What would be the minimum that they need in order to continue with the work? So I can't really give you like an exact response to that, but yeah, making that trade-off in terms of time and perfectness, I would say, and then thinking about like how much is actually needed by the people who are gonna take a look at the documentation. Hope that helps. Is there anything else in the questions?
That's it for now. Thanks, Heidi.
Perfect, thank you. All right, in that case, I'm gonna continue on with the next section, which is on collaboration. So yeah, so the suggestion is here I already have 3 suggestions. Number 1, collaborating through Git is something that a lot of people writing code do it nowadays. There's obviously other systems similar to Git that people can use, but Git is, I think, the most prominent that people use at the moment. And if you want to learn a new system for version control and collaboration, then I suggest thinking about Git, because that's what I would say 95 or more of people use these days for version control of code and also, collaboration workflows. So I learned Git, or I learned about version control also during my for my bachelor thesis, and it just completely changed my way of working. So I got a lot more organized, and it just changed the way I thought about how we work together, but also how we keep different and older versions of our work, not only code, but you can also version control other things through Git. So if you haven't learned it and you're writing code, then if you take one thing away from the session today, that will be the thing that I would recommend to take away. Learn Git. It's amazing. So the second suggestion is describing your work so that others can contribute. And I'll show an example of that in a minute. But essentially, I talked about documentation in two terms, right? I talked about like documentation in terms for users, but also for contributors or people who come to the group later on. And describing your work so that others can contribute is the kind of documentation that's for the latter case. And then the last point is use issues. So that's essentially, issues can be a forum where people put in their problems or ideas, what can be done in the future, bugs that they find, questions that they have about the software. This just helps a lot with collaboration and collaborating effectively. So let me give you an example of a very, like, my favorite collaborative project. And this one is not like, it's not a software project, but it's set up with Git and GitHub and everything. And you can take this, the way the Turing way works together, how they collaborate, and put that in a software project, no problem. So the project that I want to talk about is called the Turing Way, and maybe some of you have heard about that. It's essentially an online book about reproducible, ethical, and collaborative data science. But it's also a community, so they understand themselves not only as the online book that people can read, but also as a community that people can join. And it has a really nice documentation. So here's a screenshot of the README. The README is even available in different languages in this case. I mean, I don't require this from anyone who's writing software, but it's really nice to see how they really think a lot about making this as inclusive as possible, this project, and having really nice documentation for what the project is about, and also, and that's on the next slide, how to contribute. They have an extensive contributing guide. It's very friendly. You see in the beginning, well, welcome to the Turing Way repository, and with lots of emojis. So it's very friendly and open, and you feel like you want to contribute right away, right? And it has a lot of different, steps how you can get started contributing. For example, they use certain issue labels for newbies so they find really easily how they can contribute. Talking about issues, I promised that I would share a little bit also about what that can look like. And this is just one example of a conversation through issues on the Turing Way repository. So the Turing Way is using GitHub for collaboration and for version control. So this is a screenshot of one of the issues that are currently open. So it's about infrastructure that the project is using, And Danny here is suggesting that for some of the infrastructure the project is using, one could move to a more open infrastructure. And so there's comments coming in talking about, yeah, I think that's a good idea. Here's some thoughts. And then, yeah, I also chipped in suggesting that for events, we could use Indico. So it's just essentially a conversation. People are really nice about things. They're putting heart emojis and thumbs up emojis. So you really feel like this is a very open, inviting community. And that's something that I would also suggest if you use issue trackers or use a forum for talking about how to improve the software. It oftentimes moves into a way where people are just annoyed with each other, and you can really read it from the way that they write the text. So having a friendly atmosphere and cultivating that as well is really, really helpful in making people feel welcome and able to contribute to the discussion. All right. Before I continue with the next topic, I would suggest we take a short break of a little bit more than 5 minutes maybe, and continue at 45, so that everybody can let a bit of air into the room and maybe take a short break, and then we'll continue at 45. All right, so welcome back, everyone. We'll get started again. And I can see the Q&A now. So, all right. Let me go to the two questions because I think they're actually relatively similar. So the first question is on, how to get started with Git. The person has no experience and wants to get started working with Git. There's a lot of good materials out there that you can use. A lot of free tutorials, and I'm gonna post a couple of that in the chat. So let me post just 2 links, and they're actually from the Turingway book, which I just talked about, on getting started with Git and GitHub. But also share with you 2 links on installation and setup for different scenarios. So the first link on installation and setup is for our users. So if you're using, want to use RStudio and want to do version control with GitLab, then that's for you. And the other one is more for like general purpose and for GitHub focused. So these are just links that I can recommend taking a look at. In general, getting started with Git can be quite scary, and especially sometimes installation is not super straightforward to everyone. So if you're struggling with that, then find someone who's learning at the same time as you. So sometimes there's trainings that you may be able to join, then that's really, really helpful. But otherwise, just find a buddy who's also learning it, or find someone who can help you if you're getting stuck, because it can be a little bit frustrating in the beginning, but once you got the hang of it, it's going to change the way you work. So I promise that not a single second in my life I thought I shouldn't have learned this skill. So it's very, very useful. And in particular, not everybody is going to be able to stay in academia and research. And this is also a super useful skill in the world out there. So just in case you're wondering if this is something that we use particularly in research, no, it's actually the other way around, and people in industry would look at us in a weird way if they knew how little version control we do for our code. So the other question goes into a similar direction. They want to switch with their team from using Stata to using R, but also thinking about starting to use Git for version control. And the person is asking about if I can give any advice on how to do these kinds of transitions because, and obviously, I fully understand that these transitions can be very scary, especially for people who have been doing their work, they do the way, well, the way they're doing it for a long time, right? So this can be really scary, and I totally understand that. So I guess my suggestion would be to, well, take it step by step and take people with you. As I said in the beginning, don't try to change everything all at once. Maybe either first start using Git and then later move to R, or first start moving to R and then later introduce Git. Because I think if you do both at once, it's going to be too much. Or it might be too much, at least. It depends on the group dynamic, I guess. And so the person was also asking about training, and there's a lot of training out there. And I don't know if that's okay, Rosie, but I'm gonna put in a little bit of a self-plug. We do offer training both with R and Git at the Digital Research Academy, but there's also quite some training videos on the HDR UK learning platform that Rosie's going to introduce at the end of this webinar, I believe. All right, so thanks for all those questions. They're really, they're really interesting, and I hope that my answers are helpful, and that I actually respond the way you asked. Sorry, Rosie.
No, I was just going to say we've just had one more question come in, so I don't know if you want to address that now or maybe get to that a bit later after you've done some more.
I'll address that right now. So that question says, in your experience in a new research project, at what point do you choose to make the code more generalized and reusable in other projects? For example, by using functions, avoiding hard-coded parameters, etc., rather than keeping the code project specific. All right. So when I think about my own research and how I did things, in the beginning, when I did research projects, I always just did it super project specific. And later I started writing functions more and more because I started getting more of a feeling when a function is needed and when it's actually just a one-time thing and I'm using this code one time and no function is actually necessary. So I think it depends a little bit on both your level of experience. So in the beginning, it's really hard to know, like, when are you gonna need this functionality over and over again, or is this just a one-time thing? Does it make sense to put in the time to make it more generalized? So I think, that's something that comes a little bit with experience, I would say. The other thing is obviously, is this code gonna be reused in some way, right? And this is something that I probably can't answer for you, but you know that better about your own project. The way it was always for me, or it has been for me, is that there's some projects where it's pretty clear that this is code that I am going to look at, that I am going to use for this one research project, and then it's done. And then there's other code that I write where it's more geared toward, okay, this is probably going to be an R package that's going to be used by outside people at some point. So for me, it was always pretty clear which one of the two it's going to be. And then obviously, depending on that, you want to be more generalized and reusable, or just focus on getting the job done and making it reusable for yourself and understandable for your future self. So these are the two kinds of projects that I've had. And for me, it was generally relatively clear which one of the projects that is. If that's not the case for you, then I'm not sure if I have a good answer how to figure it out, I guess. Yeah, think about it, I guess, and talk about it with the people that you collaborate with, the people in the team, is, I guess, my suggestion. And I hope that answers the question. All right. Okay, I'm gonna start sharing my screen again and go back to the slideshow. And we're gonna continue with one final block of suggestions. And this is use automation. We have more and more complex research pipelines that are where the pipelines are essentially the code. We want to create research projects and code projects and software that is actually that works well, and using automation can be a tool to make it feel more smooth, and just taking out that those errors that we get through the human because we're humans, we make mistakes, and if we can automate away some of the potential mistakes that we can make, then that can be really helpful. So the three suggestions I brought for automation is creating reproducible pipelines. So thinking about like what are the steps that belong together and how do they belong together. I'll talk about how to do that in just a minute. Using automated tests. So testing your code, especially if it's software projects rather than just a simple script. And then finally, using what we call CI to CD, so continuous integration, continuous development. These can be automations like GitHub Actions, for example. If you haven't heard about that, that's not to worry. This is one of the more advanced steps, I would say. But if you are getting towards being more advanced and wanting to automate your code and your software more and doing automated tests and everything, then I can very much recommend checking out CI/CD a little bit further. Let me talk a little bit more about what I mean with reproducible pipelines. So one example is creating, so this is more for the people who write scripts for their research project rather than thinking about software in this case. So one of the things that I really love as a researcher is combining the paper text with the code that produces the tables and figures in the paper. That just makes me very happy. I can automate away all of the tedious copying figures from somewhere into the paper and then having to restructure it over and over again. I can I can forget about that tedious process because there's tools that let me combine the two. And this is, again, I'm sorry, my examples are for our users because that's what I am, but there's similar things. So for example, if you use Quarto, you can use that with Python as well, and Julia. So just here, one quick example of using LaTeX with R. There's similar things, as I said, with not LaTeX, but Markdown. If none of these words mean anything to you, don't worry about it. If you want to get started combining your paper text with the code that creates the figures and tables, then take a look at Quarto or Knitr. It's really, really helpful. Okay, I'm gonna start from the beginning. What is going on the slide? This is an example from my software paper that I wrote for this Model for You package that I talked about earlier. And on the left-hand side, you see the text, and then there's the green boxes where we see some code. And then on the right-hand side, you see the output when this is rendered into the PDF. So on the left-hand side, you see the original, how I wrote it, and on the right-hand side, you see the paper, how it comes out in the end. And since this is a software paper, you see on the right-hand side that there's still code in there, but you can hide that in your normal, regular papers if it's not a software paper. So in this case, what we see here in the green box creates a table with the estimates and then the confidence intervals. And at the bottom here, you see another green box that just creates the graphic, the plot, and I can put in some settings, for example, how the figure height and the figure width, the figure caption you see here. This is the caption, and it's shown here below as well. So this is me combining the text of the paper with code, and I don't have to worry if I need to change the data a little bit at the top of the paper. Then all the tables and figures that are down the line are going to be updated automatically. So this is what I mean with reproducible pipeline in terms of automation. This is really, really helpful and something that I don't want to miss anymore. So I hope that was helpful for you as well. Again, knitr, R Markdown, Quarto, these are the things that you want to look for if you want to try this yourself. So there's different tools that you can use, but they all essentially do something more or less the same. Jupyter for people who want to, that's another tool as well, if you're Googling right now. All right. There's another tool that I want to recommend when it comes to automation. This is quite an old tool that's been around for a pretty long time. But there's this rule, and I forgot the name of that, but it says essentially most tools are going to be around as long as they have been around. And Make has been around for such a long time that I think it's going to be around for a while longer. So what does Make do? Make allows you to automate all kinds of things, including it helps you automate your research project. So here, for example, this is essentially the way Make works. So you have, first you start with the target that you want to create. So I want to create a PDF that's called main in this case. So this might be the main paper that you're writing. And then you have the files that this target depends on. In my case, these are two TeX files. So and then here down in orange, we've got the code that we need to execute in order to get the PDF from the dependent files. And in this case, the command that we're using is called PDF LaTeX. Yeah, so what does this look like in an actual research project? Here, again, I use the same colors as I used in the previous slide. So here in yellow, you see the targets that we want to create. In green, you see the dependent files. And in orange, you see the code that you need to execute to get that file. So let's go to this example. This is essentially very similar to the one that we saw before. We want to create the PDF file, and we have a TeX file that depends on that, that this depends on, and a BIP file. What those different files mean doesn't really matter that much, but this is the code that we need to execute to actually generate that. Why you need to run PDF LaTeX 3 times, don't ask me. That's how it works most dependently. This is an actual Make file that I used for this paper that I talked about earlier. So if you want to get more into Make, again, there's a really nice chapter in the Turing Way book about how to get started with Make. All right. We talked a lot about different things you can do to get started with being a better coder for research. So moving towards research software engineering and how to get started with it. And the 4 topics that we talked about is getting organized, creating useful code for the people that have to work with it later and for you users, writing code together, and using automation. So these are the 4 things or the 4 overarching topics that I would suggest getting started with. And again, I talked a lot about very many different things, and you don't have to do all of this right now. If you pick one of the things that I talked about today and implement that for your own work, then I'm already super happy. So don't feel like you have to do this all at once. It's totally fine to take it step by step. I hope it was helpful, and I hope you have lots of questions and comments and but are not too confused by the things that I talked about. And with that, I want to take another quick look at the Q&A to see if you have any questions. Okay, I see currently no open questions. But feel free to just put them in the Q&A as they come to you. I'm gonna wrap up in just a few minutes, but I want to give you the opportunity to ask more questions because we do have a little bit more time for questions, actually. All right, but before I wrap up, I want to make a statement saying that when we talk and think about research software engineering, we really need to also talk about responsibilities and how we change the culture in science. Because at the moment, what we have is a culture where when people care about code, they're often, well, they're often told to focus on the papers, right? So if you're a PhD student, if you're a postdoc, you might find this conversation here on the left-hand side familiar, that you feel like you have to still document more and improve the code so that it's actually trustworthy and reproducible, but maybe your supervisor or maybe also your institution tells you like focus on the papers. That's what's important to have an academic career, right? And if people who have coding skills leave academia or go to a different institution where they feel more valued and understood, then we always have the situation that people are disappointed because actually those people who care about the code, they're doing good work usually and oftentimes, and they're actually very valuable in terms of, well, if you care about code quality, you're producing good quality research, as we said in the beginning, quality software, quality research. So I want to also say that leaders, you have a responsibility here to change that a little bit and to allow people to focus on the code to actually improve the quality of the research, right? So that's something that I just want to say, that people and researchers and everybody who needs to work with code, they need time to actually do that, because all of the things that I talked about today, they do take time. They sometimes also save us time, especially the automation things and the good organization. They will save us time in the long run, but learning all of these skills and implementing them for the first time, it needs time. So good code needs time. So we need to give people this time, and this is something that I don't want to neglect when talking about research software engineering and getting started in it. All right, if there's one takeaway that I want you to take home with you today, then if you don't do so yet, get started using version control, get started learning about Git. I think this is a very, very important skill, and it's useful for you both now and in the future. And that's something that I will dare to promise. So if you take one thing away from this webinar today, and it's learning Git, then I'm already more than happy. All right, let me check again if there's any questions in the Q&A. And I see currently none. So you still have some time to ask questions, I guess. And otherwise, I'm gonna open the slide deck again to let Rosie talk a little bit about things that are coming up in the future.
Thank you so much, Heidi. That was great. And yeah, it just gives a couple more minutes for people to post any questions if they think of any, while I talk about some other things that are going on from the Health Data Research UK training team. So if you'd like to hear more from Heidi about this topic and get a more hands-on in a more hands-on workshop, then we're running a Research Software Engineering for Health Research workshop series, which starts on the 30th of this month, and there are still a small number of places left to book on that. So I think Katie's just posting some links into the chat as I speak, and there's a QR code there as well to the events page where you can find out more. And also, as Heidi mentioned, our online learning system Futures has relaunched this week. So that contains lots of online self-directed courses, including a bite-sized video series on research software engineering in health research, along with lots more. It's all completely free to access, and there's a QR code there as well for you to sign up and start exploring. And so that's it from us. Let me have a quick check. I think we've got maybe one. Oh no, that's the chat. So yeah, I don't think there's any more questions. So I think it's just down to me to say thank you so much, Heidi, for joining us today and for delivering that great webinar. And if anyone does have any questions for us or questions that they think of later that they would like us to pass on to Heidi, then you can just get in touch with us via email and we can relay any questions over to Heidi. So I think that's that. So thanks everyone very much for joining this afternoon, and I hope you all have a brilliant rest of the day.
Wonderful. Thank you all.
Thanks.
Bye-bye.